Hello everyone, let's understand minimization of DFA in this video. So here is a DFA diagram that is given. We need to minimize the DFA. So to understand what is minimization of DFA is, we are going to be having the reduced states for the given set of deterministic finite states. We will see that whether we should be able to reduce the total number of states. Assume in this case we have around 5 states, and in the resultant we will be having less than 5 states. Maybe it could be 4 states or 3 states, which is going to be performing the same operation as this original DFA. So it is minimization is nothing but it is the application is optimization. With this less states, it should be able to perform the same operations. So this is a concept of minimization of DFA, and the technique that we are going to be using here is MinDFSM technique. In the MinDFSM techniques, what we are going to be doing is that we are going to be clubbing together all the equivalent class. Okay, we'll call it as distinguishable and indistinguishable. Indistinguishables are clubbed together. It means that they are all same. We are going to be clubbing them together, and distinguishable we are going to be having a different states. So using the equivalence class partitions, we are going to be doing the minimizations. So let's go and see how we should be able to do the minimization. So I have written the transition table for this one, the given set of diagrams. So the very first step is, first we need to have partitions. How we are going to be making the partition is, final state is one class. So if at all you have only one final state, make it one final state. Similar fashions, one more non-final state as one class, Q0, Q1, Q2 and Q3. So this is one class. This is class 1 and this is class 2. In the initial partition, we will have final state in one class and non-final state in the another class. So we will see that how we should be able to do the partition. Since final state is only one, we cannot do the further partition. So we'll go with the non-final state. So we'll see the transitions Q0 with A, where the transition is taking. Similar fashion, the transition of Q0 on B, where it is going to. So Q0 on A, it is going to Q1, and Q1 comes in the class 2, that is Q0, Q1, Q2 and Q3. So it is going to class 2. Similar fashion, Q0 with B, it is going to Q3. So this is also going to class 2, that is Q0, Q1, Q2, Q3. Okay, in the initial partitions, we are going to be saying that this is all equivalent. Okay, so it is going to class 2. Similar fashions, we have to do it for Q1 now. Q1 with A, where the transition is going to, Q1 with B, where the transition going to. So Q1 with A, it is going to Q2, again it is going to class 2, that is Q0, Q1, Q2, Q3. So it is class 2. Similar fashion, Q1 with B. Q1 with B, it is going to Q4. Q4 is in group 1 or class 1. So it is 2 and 1. So now you can see this is going to 2 and 2, this is going to 2 and 1. Similar fashions, we should do the transition. We need to check the transition for Q2 state and Q3 state. Q2 with A, where it is going. Q2 with A, it is going to Q1. Q1 is in class 2, that is Q0, Q1, Q2 and Q3. This is going to class 2. Similar fashion, the transition of Q2 with the B, where it is going. Q2 with B, it is going to Q4. So it is going to Q4 means it is going to class 1. From this we have to refer this and this. Now, similar fashions, we are going to be doing the same procedure for Q3 as well. So in the Q3, you can see now transition of Q3 with A, where it is going. The transition of Q3 with B, where it is going. So now let us try to see that. Look into the transition diagram. So here Q3 is going to Q2. Q2 is in class group 2. So it is Q0, Q1, Q2 and Q3. Similar fashion, Q3 with B, it is going to Q4. Q3 with B. Please refer to the transition table. See, this is a transition table I am referring to. Q3 with 2, it is in the class group 2, hence I am rating it as Q0, Q1, Q2, Q3. So you have to rate the class only, complete class you are supposed to be rating. Similar fashion, Q3 with B, it is going to Q4, sorry, this should be Q4, okay. So it is going to Q4. Now let us try to write, this is going to which class? This is going to class 2 and this is going to class 1. So now you can see this is going to 2, 1, this is going to 2, 1, this is going to 2, 1, except Q0. Q0 is going to 2, 2. So you can see this is going to 2, 2 class, whereas this is going to 2, 1, Q1. Similar fashion, Q2 is going to 2, 1, this is going to 2, 1. So 1, 2, 3, all these threads are going to the same classes, but Q0 is going to a different classes. So hence we have to make the partition. How we are going to be making the partition is something like this. The partition would look like this. The Q0 will stay as it is from the previous state. You cannot do further division. Q0 will be the same. So Q0 will be distinguishable because it is going to a different class, whereas Q1, Q2, Q3 are going to the same class, hence we are going to be grouping it as a equivalent class. You can check students here, Q1, Q2, Q3, all of these are going to the same set of the classes. In the very first step we had 1, 2 states. Now in the second step, we will be having 1, 2, 3 states now. Okay, so in the steps 2 we are going to be repeating the same process until we find no further splitting. So you cannot split Q4 because it's already single. You cannot split Q0 also. You can split Q1, Q2, Q3. Now let's try to check that the transition of Q1 with A, where it is going, the transition of Q1 on B, where it is going. So let us try and check here. We can go back. So Q0, Q1, it is Q1 with, you can check here, the Q1 with A, it is going to 2 and 4. So 2 is in which class? It is in class 3. Okay. So it is in class 3. So it is Q1, Q2, Q3. Similar fashion, Q1 on B, where it is going, you can check. Q1 on B, it is going to Q4. It is going to Q4. Okay. So this is class 3 and this is class 1. Similar fashions, we need to check it for Q2 on A, where it is going, the transition of Q2 on B, where the transition is going. Q2 on A, so we'll reduce the size of this. Q2 on A, so we can check it from here. Q2 on A, it is going to, students, here, Q2 on A, it is going to Q1. Q1 comes in group 3, that is Q1, Q2, Q3. Okay. Similar fashion, Q2 on B, it is going to Q4. So you can see that it is going to 3 and 1 classes only, groups only, or you can call it as group only. Similar fashion, the transition of Q3 on A, the transition of Q3 on B, where it is going, let us try and understand. Okay. So Q3 on A, it is going to Q2, so it is going to Q1, Q2, Q3. Similar fashions, Q3 on B, it is going to Q4. So now you can see that it is all going to 3, 1 group. 3, 1, that is 3, 1. This is also 3, 1. And this is also 3, 1. 3, 1. So you cannot split because it is all going to the same class. You cannot do the further splitting. No further splitting is possible. Further splitting is possible. So hence what we will do is that we'll stop at this moment and we'll draw the minimized DFA. So now the total number of state that is left is, it is Q0 and Q1, Q2, Q3, and Q4. So this is the total number of states that is left. So let us try to draw the deterministic finite state machines for this one. So how we can draw the DFA for this one is very simple. So you can check the table also. Q0 with A, where it is going to Q1. Q1 is in the group Q1, Q2, Q3. So all of this are, further we cannot split it, hence it is all coming into the same group. Similar fashion, Q0 with B, it is going to the same set of group, that is Q3 only. So it is A comma B, it is going to the same set of group. Similar fashion, Q1, Q2, Q3. Q1 with A, it is going to the same set of group, so it will be in the same group. Similar fashion with B, it is going to Q4. It is going to a state called Q4, and Q4 is the final state. Students, please refer to the transition table that I am talking here. Similar fashions you can see Q4 with A and B, it is going to the same state, that is what? It is A comma B. So now can you understand here? Now earlier it was taking around 5 states, and now the minimized state is going to be taking only 3 states. It is all going to be performing the same set of an operations. Thank you. Okay, similar fashions, here is a minimization of DFA using a min DFSM technique. So this is a DFA diagram. So we are going to be making the initial classification of the partition. So 2 and 4 are the final state, and 1, 3, 5, 6 are the non-final states. So we'll have 2 groups. Final state one group and non-final state the other group. So this is a very first step. You need to write like this only for your examinations also. So checking the class 2, 4. We need to check that the transition of state 2 on A, where it is going. 2 on A, it is going to 3. See, you can write a transition table, that would be better actually. Okay, transition table, write it and then refer. See, it is going to 3, and 3 is in the class group 2, that is 1, 3, 5, 6. Similar fashion, 2 on B. 2 on B, it is going to 6, which is in the class group 2, 1, 3, 5, 6. So we are going to be writing it as 1, 3, 5, 6, 1, 3, 5, 6. 4 on A on B. So you can refer to the table. 4 on A and B, it is going to the same group, that is 6. 6 is in the class group 1, 3, 5, 6. Similar fashions, 4 on B, it is going to 5, that is 1, 3, 5, 6. So hence we are going to be writing it as 1, 3, 5, 6, 1, 3, 5, 6. Similar fashion, check it for the class group 2, 1, 3, 5, 6, where it is going. It is going to 2, 4, 2, 4, 2, 4, 2, 4, and 6 is going to 1, 3, 5, 6. Since it is going to a different class, we are going to be putting that inside a different class. Now we are going to be splitting. Earlier this was one group, 1, 3, 5, 6 was one group. Now we are grouping as 1, 3, 5 is going to the same class group, whereas 6 is going to a different class. So hence we are going to be splitting it as 1, 3, 5 and 6. Now the step 2 will have 3 classes, 3 class group now, 2, 4, 1, 3, 5 and 6. So 2 on A, it is going to 1, 3, 5, 2 on B, it is going to 6. Similar fashion, 4 on A, it is going to 6, 4 on B, it is going to 1, 3, 5. So it is going to different classes. So we need to split 2 and 4 also, but 1, 3, 5 further splitting cannot be done because it goes to 2, 4, 2, 4, 2, 4 only. So further splitting is not required, so you cannot do the further splitting, and you will be able to construct a DFA. 1, 3, 5 is equivalent now. 2 and 4 is splitted. Now these 2 are the 2 new final state, and 6, it is going to 4 states. So we have from 6 states to 4 states.